a project and just a single line causes issue with your production application. But before we even go, how many of us are software engineers, front end or back end? Okay, front end first, okay, then back end. So I'm talking to everybody, because at least we are trying to ensure that we ship faster, and because even though you're a back end engineer, there are some things you need from Firebase, like your FCM and the likes. So there is something that we could do that just a single piece of code or a single line could disrupt your entire years of sweat. We all know this, just a single, sometimes it can even be a semicolon, and it will scatter your whole project. And also, what if the feature that you just shipped, because what makes an entire application is multiple features, right? Feature 1, feature 2. Then what if you just added a new feature, and it is that new feature that makes your whole application go crash? Now let me give us an example. A few months ago, somebody vibe coded an application. We all know vibe coding back. So he vibe coded from A to Z of entire startup product, and it shipped. And under a week, it was hacked. Like complete startup. So it might use a month, 3 months or more to build the whole product. But when he shipped, so they launched, they even raised money. So it was the same week that they launched that they got hacked. So we don't know if it was a feature that they shipped last that caused that issue, but we can't say it is vibe coding. Now we are bringing it back to Firebase. So Firebase is trying to ensure that if you are building an application, we have Firebase rules behind the scene, right? Now your Firebase rules can also cost you a lot of money, like that other man. Because imagine you make a rule and you just say allow write, read, or updates if true. Nothing is checking nothing. So, which means anybody on the internet, anybody that has access to your API or to your app, have access to read, to write, and to even update your entire production application. And that is what Firebase can do for you. You can see, I say allow read if true. But now, I want us to start thinking about this. I have to add this image because they said they are coming to Nigeria. So security should not be something that we will trade off. From the day you are thinking about that idea, either as a company, as a startup, or as a sole developer, security should be the first thing that you think about. Many companies do not have money to hire a security dev, pen testers, but you can architect your products in a way that security is at the forefront. Now you look at, let's say you want to do, there's this particular one, idempotency, yes. Now, what's that? I think people that work in fintech will embrace idempotency more than we are doing more like crude, creativity, update. Because in fintech, all of us can make a write or a read at the same time. Then we want to now write to the database at the same time. Now you want to withdraw. Now what this guy did is that if you are sending money to maybe to your friend, and then in that split seconds you try it and then your network went off. Now you make the request. Now if your network come back again and you now make the request again, it should not go twice. It should only go once. But I think the Momo boys, they tried MTN one time like that, and that thing affected MTN, and they bleeded up, I think, billions of naira that they bleeded. Now that is what idempotency can cost you if you don't think about it. And it is not because you are not experienced, it is because security is not what you are thinking about. It is when you think about security, that is when you think about idempotency, what happens when people are trying to write at the same time. When I was doing that small app that you was scanned now, I think about it that what if a lot of people are trying to scan at the same time and they're trying to submit at the same time? The differences is in the nanoseconds that you submit. We all play out. So you can all score the same question, but the time at which you submit matters a lot. So security should not be something that you play around with. It should be part of your CI culture in your organization. So I'm talking about securing your Firebase apps. and I'll be laying more emphasis on Firebase Rules. And my name is Ayodele Aransiola. Day to day, I do developer relations, solution architecture, open source advocate, and at the same time, I also do apply to Maguire, so co-founder at Ayodele Learning. Alright, so on X, you can find me at Helium of Things, and if you see me in your group chat, probably you will see that name, Helium of Things. Alright, so how many of us have been in this situation before? Just make it work. Don't lie. So it means that almost all of us have been in this situation. Now, your CEO, your CTO, or your company are not interested in how it works. Their own is just make it work. But we are losing three things. The first thing we are losing is security. Because when you just want to make it work, do you think about security? No. What I'm talking about is you shall work. Scalability. When you are doing just make it work approach, are you thinking about scalability? No. They are just trying to make it work. Then the last one, there's no S in compliance, but I just want to make it 3S, so that's why I add S. So it's compliant. Now, when we talk about compliancy, being compliant in either you are playing in the fintech, hospitality, any industry you are playing with, there's still a body that ensures that whatever you are building, you are being compliant. Now, but when you just want to make it work, we think about compliancy. No, because you just want to make it work. Now, this will now lead us to where we are going. All these ones are just building blocks to the deeper part. Now, rules on Firebase, they are not your backend logic. It is just like a yes or no something. You are making a request. And what Firebase rule will do is that this request is coming. Should I allow? Yes. Should I deny? No. So that is just what Firebase Rules is doing. Your logic is static, or it is dynamic and it is working. But the rules is just ensuring that this request is coming in. Should I allow that request to pass, or should I deny that request? Now, if you look at the first example I gave, when we said allow read if true. Now, Firebase Rules just say allow the person to read, so far it is true, and it will be true because once the request comes, the first check it will be allow read and if true. But assuming there was more checks done, it will first deny before it now allow that. Now that will take us to the next one, which is if you look at this example. So can we off the light? Okay. So if you look at this example, it says match users. So this is your route. And then we say allow read and write if true. This is not a secure pattern. And any request coming in now will just go. Now if you allow read, you allow write, even we allow update or delete, all of them will go through. Now let's check this one. This is a deny first approach. And then we are not giving you access to perform any action based on your intent. Now if you look at this and compare with the previous one, now we are checking your authentication ID and ensuring that it matches your user ID. Probably, let me talk about the document structure on Firebase. We don't use table, we use documents. So you have a document for users, and you now have another document for, let's say, authentication. Okay, Firebase has authentication separately. So you allow authentication, then you have to ensure that the authentication ID of every sign-up matches the user on the user documents. So now you are now comparing the two, that when the request is coming, the authentication token has an ID. Does it match the user's ID on the user documents? So if it matches, then allow the person to read, then allow the person to write. So that is what we are doing now. So our first action here is that deny first, then allow the person to perform the action by intent. So we'll still go to more deeper part. Now, what we're trying to do is that everybody can have access to this room, but not everybody can come to take this mic, right? We all have access to this room, but not everybody can take the mic. That is what we are trying to do with Firebase Rules. Now, we are building an application that has multi-tenant, that has which example again? Maybe a SaaS application that has multiple people that need multiple access. Or you are building an app like Google Doc, which one again? Google Doc, Trello, all those apps that are SaaS products. Now, there's something that we need, and we need admin users, we need viewers, people who can just read. And the reason why I added this is because I said we need, we trade off three things if we don't put security in our forefront. The first thing we did not think about is security, scalability, and compliance. Now, if you want to be compliant, there's sometimes that auditors will come and audit your product. You don't want to give them admin rights. The only thing you want to give them is just viewer rights to come and just audit your product. And if you are doing ISO 27701 or you are doing which other one, SOC 2 or SOC whichever one, the auditors will come and audit your entire product. Now, those people that are coming, they are external people. Even investors that want to do due diligence, they want to see your numbers. You can give them access to your back office, but you won't give them admin access. You just give them viewer access, but for what? Audit purpose. I'll still give us a much more robust example with Firebase. Now, field immutability. This is not really clear. So let me just read it out. Now, in the first part, we are trying to make intent. Who and what can they do? So in who, like the previous one that I said, authentication ID must match the user ID. Now, and I said they are making a request. That request that they are making, the request comes with a row. Now, does it match the row they have on the application? Now, hackers, they always try to break the communication between your client side and your server side. Now, what we're trying to do here is that even though we want to give you access to read, now we added this clause, and so the two must match. So we are trying to let them know that even though you are coming, even though you hijack the session, by the time it is hitting the server, we will still compare what is coming. Does your row before and your row now match in the same way? So you are doing a check as it is coming. So you check what is happening previously, comparing with what is happening currently, to check if the row match. And if they match, then allow them to read, allow them to write, or allow them to update based on what the request is coming to do. So sometimes users just need the access to read their contents, but you don't want them to be able to update some fields like their, let's say, their email, their rows or balances. And hackers, this is what they're targeting. So you want to ensure that you are checking the request, then you are checking the result that is coming. Does the authentication ID, because when Firebase sending auth token, it comes with an ID. So you can also check the rows that ID has. So if you use custom claim, so you can use custom claim to make to declare your row. I prefer using custom claim than setting a table in the either in the DB or your documents. And you now have a table called what do we always call it? The rows table, where you now have admin, sub-admin. I don't usually do that because for me it is not really secure. But if you are using custom claim, it is from the server you are declaring the role for that particular user. So anytime you make an authentication token request, it comes with the ID and the role. So you are now checking the role of that person in the auth token and checking with what the person has in the user table. So in that way, we are blocking their intent. This is much more elaborate. So this is people building something like maybe block and the likes. So you have a post route. Now I want to allow you to create, but this is just what I need. But I need to make it more secure. So I'm saying that your request resource, does it contain the same owner ID, which is also the same as your UID? And you can notice that we are making different ID to still match the user ID on the user's document. So we are ensuring that the person who is writing to the table is the owner and still the user, and the person who is also reading or deleting is still the owner and still the user. So this example is just for us to ensure that the user can only touch their own item. Are we lost? Okay. So multi-tenancy. multi-tenancy in some context says that you are building, now let me now pick a product now. You are building an invoice app. Your invoice application will not only be used by users, basic users alone. It can be used by companies. Now, if it's being used by a company, you don't want to build it for just one single company. So you want to build it for multiple companies. Now, there's something we can do as a backend developer, or there's something we always do. If it is multi-tenancy application, we always create multiple tables for different organizations. But that will cost us a lot in terms of the reading time. Because you have to fetch and join multiple tables to make just a read request, or just to make a write request, because we want to ensure that the tables in SQL we have to do maybe outer join, inner join, or right join. Then when you create the join, you now make that call. It is expensive. So what if you just have a single table and you can make a call that it will just check your tenant ID and give you what belongs to you. So business A and business B, when they are signing up, you assign them a tenant ID. Now, remember that we are now having multiple things to check who you really are. So we are giving you owner ID, we are giving you authentication ID, we're also giving you user ID. Now, it has become three things. Now, we are now adding tenant ID for, let's say, for example, an invoice application. For sometimes you don't need the four. You just need to pick the user ID and now maybe the tenant ID. You just want to ensure that when the request is coming, the same person is making that request. So on your table, or let me say on your document, you are trying to create a is it decimator, or what can we call this? Something that will just differentiate people in that single table. Then you call it tenant ID. Then you give each person that is signing up a different tenant ID. Now let's see the implementation. So when you are signing up, we've given you a tenant ID, and now your auth token is also coming with a tenant ID. So we are ensuring that when you are making a read request, or when we are trying to create anything in our invoice documents, it carries your tenant ID, and when the authentication is also coming, it also comes with a tenant ID. So you match the two. You can see that it's even the same with the user table. The only difference is that this is called tenants. So we are trying to ensure that the call is not expensive. You can check millions of data with in just seconds, just because you are trying to filter based on tenant ID. And then when you are checking existing data, now you are allowing them to read, to update or delete. If this and this. Now, many of us don't usually use this before because we may not know that it exists on Firebase. But now you know that your request has a resource and it contains a data. Then you can also check the tenant ID that is coming with that request, then use it to check the authentication token, because what Firebase Rules does is to what again? To allow or deny any action. So when it hits Firebase, then rules will come in check to compare these two that is coming, and then you allow the read, you allow the update. Now, which means we are not just writing rules to allow your application to go public. We are writing rules to ensure that whatever we are building is secure, and we are entrusting our is it entrusting? Yes, we are still entrusting our data to, let's say, Google to keep for us. But you already know that nobody that is coming have access to user data unless it is their own data. Even though they try to hijack the session, they still have to be sure that it is still their own. Okay, so we've built the whole application, but if you did not test the security, it is as if we are just disguising. So when you are done building the application, it is very paramount that we test how secure it is. So if you don't have enough funds to hire a security tester, you can outsource. It can be once in 3 months to ensure that there's somebody who comes to test your app. Because if you are collecting people's money, you should be ready to spend money to ensure that the app you are building is more secure. So security that is not tested is insecurity in disguise. Alright. I also want to introduce us to something again. So for people building collaborative applications, or let me ask this question: how many of us can explain how Google Docs works?
Okay, good day everyone. My name is Steve. Then Google Docs works in a way that you have different level of access, which is the read, I think that's the viewers part, then I think one other one before the editor. So in the second one, which is like the author, you can see some things and then you can write some things. When I mean write, I mean like reading and writing code. So but the other editor access, you have full access as the person that actually created the document. So you can change anything and everything on that particular docs. But with the author access, there are some things you cannot change. While with the viewer access, you can just read, you cannot change anything.
Good day everyone, I'm Oluwatosin. So from another point of view, the way Google Docs works, it doesn't just work alone. It works alongside OneDrive and Google Cloud. So, of course, we all know Google Docs is an online word processing platform. So, you create your document, then it saves on your OneDrive, and I think cloud should be that is stuff that joins them all together, right? So,
okay, thank you for the contribution. They are all correct. Now, do we now know how Google does the role switching? Do we think they created a role table that once you give this person access to the document, they get assigned to the role? Okay, so let me expose Google a bit. So there's something we call ACL. So ACL means Access Control Model. For football fans, any player that hear ACL, they don't be for you. Now, there's Access Control Model. Now, there is no role table. The thing holding access to the document is the document itself. So, let me use, what can I say as an example? I'm having a birthday party, so I give everybody an invitation card, but the card is blank. So which means anybody can be stopped on the road with a gun on their head and they collect their card back. Now when you now get to the door, I now hire a bouncer with a big chest and say, okay, let's check him in. I will now check the guest list. So I will now request for the card that you are giving. Oh, you have a card, now give me your identity card that shows that you are the person, that carries your picture and your name. So I will now use that to check my guest list. So it is until then you can enter. That is how Google Docs works. The access list is on the document, not on the user profile. Now, so if you are now building an application that, let's say you have 1 million documents, you only want these people on this row to have access to document 1, document 2, and document 5. Then these people on this row to have access to document 70, 80, and 100. Now, do you think you want to create different rows on your DB for them, and you have 1 million data? Now, you see that if you check your rows table, your row list will be long. But if you just create an ACL, so what we have now is a document level ACL. So you know that ACL is access level list. But document level now means that we are not giving the document the power. So on your document, you create the file, then you now create the project, which is the document that you want to access. You will now create a list of people that will have access to the document. So the document itself is the one carrying the access list. So if I now want you to access the document, what will I do? I'll just add you to the list under the document. So if you are coming, once you get the document, you just check if you are in the list or if you are on the list. So if you are not on the list, you don't have access. So if you are on the list, and the list, the access you have is just view. You will only be able to view. And if you are on the access list, you are only allowed to update. You able to update. Now you cannot say that you are coming empty-handed. But when you get there, the document will decide which role or which action you can perform. Is it clear? Yeah. Now this is a code snippet that explains a document level access level on Firebase. Now we are allowing read. Now this is all statements, right? We are allowing read, and under the data we have viewers and we have editors. So if you are on the viewers list, you have access to view. If you're on the editors list, you have access to edit. Now we only want those in the first list to be able to edit. Now you can now see that we are making, this is the route, but we are giving two separate access to a document. So document level access gives us the power to build a robust application, but limit the number of rows we are declaring on our application. So which means there is more to Firebase than we know. So which means we know that we can create a document that has different rows. But what if I don't want to stress myself? I just type the row to the action. So when you are coming, so the person that is having the super admin row, you just add people to the documents, and once you add, you can view. So when you are now making that request, so what does it check? Auth ID, and check if your ID is in the viewers list. So you can use your ID to perform multiple requests and check to ensure that something is happening. And the reason why I love this is because this is also happening on the server side. So that is why I love using custom claims. So this happens on the server side and check before the read happens. Alright, so you can't improve what you don't monitor, because it is something that you monitor that you can actually improve. Because if you don't monitor it, imagine you have a plant and you don't know if it needs water, you don't know if it is suffering from anything, air, water or sun. So how do you want to ensure that it is growing? So you can only improve what you monitor. And I have some audit checklists for us. Either you are building solo, you are working at a company. I want you to go back to the office on Monday, and when they're talking about Firebase, or maybe you have implemented something before, you cannot say, we can do this better. And